Why Nevada holds massive lithium reserves. The state of Nevada in the United States has the ideal combination of topography, climate, and geological activity to become a significant global lithium production hub. In Clayton Valley, a vast basin in Nevada's Esmeralda County, turquoise-colored pools sit amid brown mountain ranges. Such basins and mountains stretch across the state, from west to east. However, the still waters in Clayton are man-made and rich in lithium. Silver Peak, a small former silver mining town in this remote valley, became Nevada's first lithium production site in 1966, decades before lithium gained importance as a key metal for renewable energy and national security. The facility, run by Albemarle Corporation, produces 5,000 tons of lithium carbonate annually, according to Live Science. Historically, lithium held little economic significance, but the surge in demand for lithium-ion batteries has shifted focus to lithium deposits. According to the U.S. Geological Survey, lithium-ion batteries, primarily for electric vehicles, account for 87% of global lithium demand, expected to rise to 95% by 2030. The U.S. currently produces 0.5% of global lithium, but Nevada could change that. Nevada has more lithium than any other state, says Christopher Henry, emeritus geologist at the Nevada Bureau of Mines and Geology, NBMG. James Folds, another NBMG geologist, explains that tectonic conditions contribute to this abundance. Nevada's lithium reserves are the product of fortunate geological conditions, with everything tied to a stretched crust, steep terrain, abundant volcanic rock, high heat flows, dry climate, and hydrologically closed basins. The tectonic history of the North American Great Basin, covering much of the western U.S. and all of Nevada, is complex. Around 17 million years ago, the Earth's crust, once thickened by ancient tectonic collisions, began stretching and thinning, pulling apart like taffy. This tilting of crustal blocks formed basins where sediment and water collected in shallow lakes. Magma, rising through the thinned crust, erupted onto the surface, mixing with gravel, sand, and clay. Most basins in Nevada today are arid, leaving cracked mud and salt flats. The crust stretching continues, creating vast lithium reserves for the state. According to Simon Jowett, an economic geologist at the University of Nevada, Reno lithium formation begins with magma rock. Most lithium worldwide is mined from hard rock, like the world's largest lithium mine in Australia's Greenbushes pegmatite. But in Nevada, lithium sources stem from rhyolite rock, an eruptive form of granite, with minimal lithium content, insufficient for direct economic extraction. Instead, geologists focus on volcanic sedimentary deposits, where weathered rock releases lithium into nearby basins. Streams often carry rainwater across land to the sea, but Nevada's dry climate and terrain create hydrologically closed basins. Streams bring water into the basins, forming small lakes. Rainwater extracts lithium from rhyolite rock deep underground or on steep slopes, accumulating in the basins as brine. In Clayton Valley, lithium-rich brine is pumped to the surface to evaporate or undergo direct lithium extraction. Beyond brine, geologists are particularly excited about Nevada's lithium-rich clay deposits. The McDermott caldera, spanning Nevada and Oregon, formed a volcanic chain as the North American plate moved over a stationary heat source. When McDermott erupted 16.3 million years ago, a lake within the caldera filled with ash and smectite clay. As the lake evaporated, hydrothermal activity converted lithium-rich smectite into elite clay, particularly in the southern part of the caldera at Thacker Pass. Today, McDermott is one of the world's largest lithium deposits. Tech startup Lithium Americas Corp estimates the Thacker Pass project holds 217.3 million tons of lithium, with production expected to start by 2028. Some 268 miles to the south, Rhyolite Ridge in Silver Peak Range contains Nevada's next lithium clay deposit. Originally, geologists thought Rhyolite Ridge's lithium-rich rhyolitic deposits accumulated in an active tectonic basin. As the basin developed, a lake formed, depositing clay-rich sediment above volcanic rock. Hydrothermal fluids seeped through cracks, allowing lakebed clay to absorb lithium from the rhyolite below. Later fault activity lifted these deposits, exposing valuable clay. Ioneer USA Corporation plans to mine lithium boron and build a chemical processing plant at Rhyolite Ridge, with production slated for 2028. Once production begins at McDermott and Rhyolite Ridge, Nevada's lithium output is expected to soar.